3. This is Unit 3, Lesson 1. As usual, you're going to look for the task to complete for U3L1. By the way, anyone notice anything different about me today?
The beard.
Lost the beard. My daughter saw me this morning, was like, what? Anyway, sorry, I just got tired of it getting in the way, and I was too lazy to actually trim it, so I just shaved it all off. But don't worry, it'll be back in a week probably. So, but all right, make sure you're looking for the task to complete for U3L1. You can find it under assignments or on the Canvas Science 2 homepage in the weekly calendar. Today's date is the 12th of November. As usual, we'll start off by throwing you into breakout rooms to chat about something. This is actually going to be more homework related. So the first question I just put in the chat right now, it's what is one thing you found interesting, weird, or surprising from the Bryson reading about the atmosphere? If you have nothing to share on that front, then you can talk about the resource that you posted to the discussion board, which was the homework. Chat about that for about 2 minutes or so, then we'll come back together to do a little bit of sharing, move on to the next thing. All right, rooms are open. Again, we'll come back together in about 2 minutes.
All righty. 5 more seconds here to let people come back in. There we go. All right, let's choose some random victims here. Molly, what's one thing you normally see a regular skydiver wearing?
Parachute.
Parachute would be important, right? It's going to slow down the acceleration of your fall and hopefully allow you to survive. All right. Quinn, what's something else you would see a parachuter wearing?
Probably goggles or some other form of eye protection.
Yeah, right. There's a whole lot of wind that you're flying through. Eyes are going to be very, very prone to that. So, called on you earlier. Samantha, what's something else a skydiver might be wearing?
Well, some helmet or like some things that to protect your knuckles and things like that.
Yeah. It seems kind of weird, right? If your parachute fails, I don't know how helpful a helmet's going to be, right? Joke then is the helmet's wearing you for protection. But yes, it is important because you still could potentially have a rough landing, that kind of thing. Anyone know what's true about the clothing that skydivers wear too? What do you notice about their clothing? Wiley?
Well, don't they usually wear like a one piece, like whole thing?
Yeah, right. You don't want the wind like ripping your pants off, right? That'd be kind of embarrassing to come down with that. It also tends to be very brightly colored. Why do you think that's important? Sean?
For other aircraft or other skydivers in the air to see you.
Yeah, right. Really, really noticeable. So you're going to stick out like a sore thumb too, especially, hopefully no passing aircrafts, but yes, that's good. All right. So how would jumping from 39 kilometers higher up be different? Anyone got any ideas? Anyone want to jump in?
Yeah, you'd be way higher up, so the oxygen, or there'd be a lot less oxygen in the air, meaning you'd probably have to wear an oxygen tank or even like a full spacesuit.
Yeah, right. So we're not going to be able to breathe. Our lungs are not adapted for collecting oxygen that is so thinly distributed in the air. So yes, you would need an oxygen supply. And very good. You'd see a spacesuit would be important too. So the reason there's less oxygen is because there's just less air, right? Air is a lot less dense. So does anyone know what's that going to mean about how fast you fall? You're going to fall faster or slower?
Faster.
Yeah, a lot faster, right? And so the same idea of like a full spacesuit, you're going to need that too, because the amount of shear and friction that you're eventually going to hit as you get lower and lower, as you're falling faster and faster, you're going to hit thicker air eventually. And it's going to be a lot more violent on whatever you're wearing. So a onesie suit isn't really going to cut it. Good. Any other ideas? What do you think the temperature's like at that kind of elevation?
Very cold.
Yeah, right. So also another reason why you're going to want a full suit or something like that. So cool. These are all things we're going to be looking at, right? How thin the air is, how cold it is. This is going to be the focus of our next unit. So unit 3 is going to be all about the atmosphere, and we're also going to talk about things in the atmosphere. So we'll talk about climate change. We'll probably look at some ecosystem stuff. So this, again, will be kind of a mix of physics, chemistry, biology as we tackle this layer of our planet, right? We're continuing to zoom in, right? So we learned about solar system, or the universe, the solar system. Now we're zooming in on Earth, and let's talk about the surface of the Earth first before we delve into the inner workings. I do owe you all an apology. I don't have your tests graded yet. Sorry for that. I will hopefully have those done by the weekend so we can review that on Monday. But today we're just going to focus on starting our next unit. So my next question to you was, do you think anyone has actually jumped from 39 kilometers up? The reason I'm able to give you such a specific number is because that is the world record. Someone has actually jumped from 39 kilometers. He did not jump out of an airplane, though. He jumped out of a balloon. So he had a balloon raise him up that high. A guy's name was Felix Baumgartner. Did this back in 2012. Does anyone know what company? I mean, some people might have seen this. Anyone know what company funded this? Does anyone know what company tends to fund a lot of this crazy stuff?
Was it Red Bull?
Yeah, Red Bull, right? So they called this the Stratus jump. So we're going to watch a little video that summarizes this, and then you guys are going to kind of delve into a little more detail about exactly what happened, what's going on. This will take up actually the next 2 lessons probably. But all right, let's watch the Stratus jump. This is going to kind of describe the whole thing. You'll see the balloon and how they inflated it and got it ready, the little capsule that he sat in to ride all the way up to 39 kilometers high. And then it's crazy footage you'll see of him actually stepping out of the capsule and then just falling out. I'm going to optimize my screen here for sharing. And again, some of you might have seen this. This was kind of all over the news. It's all over YouTube too. Here we go.
We got to get Felix off the ground safely and not tear the balloon. And we need optimum conditions. So as the weather person here, we're going to be very, very, very picky in picking the right conditions.
Felix has completed his physical.
I've been working 4 years on the program. I believe in what Felix is trying to do to test the next generation full pressure suit. And I'm just delighted to be a member of the team.
This is mission control at this time. Felix is departing his Airstream trailer to be strapped into the Stratos capsule.
I will assess the situation again. We will not start inflating as soon as the balloon's completed laying out.
Copy
so there'll be another small hold.
T-minus 1 hour, 13 minutes. We're going to go on hold.
Chuck Yeager was the first man to go supersonic in an aircraft. It was 65 years ago, and I think it would be just absolutely wonderful if we could get Felix to go supersonic without an airplane on the same day that Chuck Yeager flew supersonic in an airplane.
At this time, we have begun balloon inflation. Capsule systems are green, instrumentation's green, payload's green, medical systems are green.
There's the release, and there's the applause, a successful rise.
This is mission control. Felix's current altitude is 25,300 feet.
We're at 108,000 feet. There is an issue with the heat in the faceplate. Mission for the time being is continuing as the team considers what are the options. So the decision has been made. Baumgartner will jump.
Sometimes your air can be up really high. How small you are. I'm going home now.
Jumper away. 20 knots. Felix at a stable descent.
Love that after all that, he landed on his feet too. It's pretty good. So yeah, a couple fun things from that. I don't know if you guys noticed the balloon inflated a little bit more as he was rising. We'll talk about that in a second. And also the faceplate issue, his faceplate kept fogging up, but they decided to go with the jump anyway. So just to share a few quick facts about the jump and what he accomplished. Again, this was back in 2012. He is the world record holder now for the highest free fall and the most time spent in free fall. So just for some perspective, right? A commercial airliner, regular airplane, flies at about 33,000 feet, which is 10 kilometers above sea level. Mount Everest, the highest point you can walk to, is at 8 kilometers. They refer to that as the death zone. It's the highest elevation, and it's not somewhere that you can usually naturally survive. He went up to 39 kilometers high, way above any of those things, right? This is usually where we send weather balloons, right? Weather balloons go up to about 40 kilometers. The speed of sound is about 767 miles per hour. The top speed they recorded for him in his initial fall was 834 miles per hour, which means, does anyone know he broke the what? Does anyone know what we refer to?
Sound barrier.
Yeah, he was technically going faster than sound for a little bit there, and no jetpack on or anything like that. They refer to it as going supersonic, really, really, really fast. Now, we'll, in our next lesson, analyze his actual fall. There's some cool stuff that happens there, and he actually kind of started spinning really fast at one point. Everyone was kind of worried, but then stabilized his descent. But what I want to focus on today is the rise, right? Because that little capsule that he was in, the balloon that was taking him upwards, they were taking outside temperature, they took outside pressure, and collected some interesting information about the atmosphere. And so I want to use that for today, the rise up, the ascent, to do a little study here. Okay, I lost my, let's shrink out this. So any other questions or comments on that video before we move on? Again, we'll be talking about Bob Gardner for the next 2 lessons. So, alrighty, I'm going to share my screen here really quickly again. We are now on the last task on the lesson. So this is step number 3, Bob Gardner's ascent. And, oh, sorry, actually, I know what I'm forgetting here. Here's one question I want to kind of pose to you that is related to our previous unit. Let's see what you took away from this. Sorry, one last little breakout discussion. That's what I'm forgetting. Okay, I'm going to throw a question in the chat here. Put you in breakout rooms one more time to discuss this question. When Felix reached 39,000 meters or 39 kilometers of elevation above sea level and stepped off the balloon, why did he fall instead of floating like an astronaut would? Breakout rooms are, hold on. Sorry, why did it, weird. Sorry, hold on, let me recreate the rooms here real quick. Why it didn't populate them properly. Okay, now they're open. We'll come back together in about 2 minutes. All right, let's let the last few people come back in. So, who's got an idea? Why didn't he float like an astronaut?
Because he was still in the Earth's atmosphere.
Very good. So I know that in that first video, it looks like he's in space, right? You can literally see the curve of the Earth from the elevation he was at. Technically, he was not in space yet, so good. That's definitely one reason, but there's another sort of bigger reason. Back to what we learned about orbits.
Is it like Earth's gravity is still being exerted, and so that it's pulling him back down? And I don't think that at that height, tangential velocity would be a factor?
Very good. In other words, did he have any tangential velocity of a significant amount?
No.
He wasn't moving sideways, right? He was in a balloon that just carried him upwards. So yes, again, that's the big take home from our previous unit. The moon is being pulled on by Earth's gravity pretty much almost as much as any of us are, right? If the moon were to stop, it would fall into Earth just like a lemon falls from a tree. The reason that he fell was, yes, he didn't orbit because he was within our atmosphere. So there's no way that he could have really achieved a high enough amount of tangential velocity without experiencing tons of friction anyway. But he also just didn't have the tangential velocity. He fell pretty much straight down. I'm sure he was drifting a little bit one way or the other, but yes, didn't have that orbiting velocity, right? You have to be in a spaceship or rocket or something like that to achieve that. Great. All right. Any other questions or comments or anything anyone wanted to share about that? Here's the activity we're going to be doing. Just shared my screen with you again. We're on step number 3, Bob Gardner Ascent. You're going to be using a Google Sheet to analyze and graph some data. So this is part of this assignment, Bob Gardner Atmosphere Ascent Data Analysis. You're going to click on that. It'll take you to this assignment where I've got very detailed instructions. Please, I know it looks like a lot, but please take the time to read each step and follow each step exactly. You're going to be watching a longer video. It's about 1 minute and 50 or 1 hour and 50 minutes. You obviously do not need to watch the entire thing. You're going to be skipping through it to collect data. What this is, it's a very boring video, but it's basically his ascent. So it's while he was just sitting there in the capsule and was rising up. But what's cool is in this video, they have these 3 pieces of data, which you're going to be keeping track of. So the first is the altitude over here on the right, specifically in meters. You're going to be looking for data at certain altitudes. Specifically, the data is going to be the outside temperature down here. I want you to pay attention to degrees Celsius, don't worry about Fahrenheit, and the outside air pressure, which is in pounds per square inch, or PSI. So you're going to be skipping through this video and filling in data on a Google Sheet. So that's what's available here in this second link. You're going to open that up. First thing you're going to need to do is make your own copy of this. So usual deal, right? File, make a copy, delete the copy of name, and then just type in your own last name. And then hit OK. I've already created my own. But what you're going to do then is fill in this data table here. So you in the video can skip to these altitudes. So skip to 11,000 meters, then 13,000, then 15,000, 17,000, and so on. You might not be able to get those exact elevations. That's okay. Just get as close as you can to each of those units. And then I would pause the video and just type in the outside temperature and the outside air pressure. Please note that the outside temperature is a negative number. So make sure you're putting a dash or a minus in front of it. And never put a unit in here or a space. We want these to be just numbers because you're going to analyze them and graph them next. I have all the graphing steps and procedures outlined here. These are the same procedural steps that you see in the assignment, so just make sure to follow those. I'll be here listening if you have questions or if you're not sure how to do something or if something doesn't seem to be working. I can get you to share my screen with me and I can walk you through that to help out. But you're going to be generating a graph that should look like this, where you're going to be graphing relative to his altitude, what happened to the temperature, and what happened to the outside air pressure. And there's actually some interesting stuff happening here. Once you have your graph done, you can use that to complete this, the Bob Gardner Atmosphere Ascent Data Reflection. If you click on that link, it'll take you to a Canvas quiz. It's about, I think, 7 or 8 questions that relate to your graph and that data. So I'm going to time for 25 minutes to get through this. Hopefully that should be enough time to collect the data, make your graph, and complete the quiz. Again, I'm here listening if something doesn't work or if you need help. Go for it. For you. So what is interesting about temperature? What happened to the temperature as he rose initially from 11 kilometers up to about 19 kilometers? What did the temperature do? The blue line. And it, yeah, went down, right? Which is to be expected, right? We expect things to get colder as you rise higher up. But then what unusual thing happened after 19 kilometers as he continued to rise. What happened to the temperature?
It increased.
Yeah, it warmed up. Isn't that weird? Now, granted, it's still below freezing, right? Notice that it's always negative. So it's still super, super cold, but it's becoming less cold, which is kind of interesting. So we'll delve into it in our next unit, and you'll do some reading tonight about the layers of the atmosphere and what's going on with that. Not surprisingly, though, what happened to the air pressure outside?
Got lower.
Yeah, right. And a lot of you kind of got at this already with your talking, or when we were talking earlier about the first video. But one thing that strikes me, and I encourage you to go back and watch the video again, is the balloon that he rose in. Initially, it didn't look very well inflated, right? It looked barely inflated at all when he was first taking off. But then if you look at the footage later, when he's super high up, the balloon is absolutely enormous. And that's because there's less air pressure outside, so things expand. It's the same reason why, does anyone know what happens to your ears when you're in an airplane?
They pop.
They pop, right? Because there's actually air pockets in your ear canal, and the air expands because there's less pressure outside of you. So anyway, this is all stuff we'll explore in our next lesson. Homework is to read, I think we're on chapter 26 now in Hewitt. You're just reading 26.1 and 26.2, but I want you to stop halfway through 26.2. So you're reading up to page 761, I think. There's like a 26B that's all about the greenhouse effect. We'll get to that later. Usual deal, submit a photo of one page of your notes, and there's a reading reflection. You have up to 10 attempts to complete. And please make sure you've submitted your graph Google Sheet and completed the quiz related to that. Questions on the homework? Thank you very much, kids. Have a good day.
Thank you.
Thank you.
Thank you.